Today, I am going to talk about the roles of AI in English learning based on a three-level model as a learning theory. I will talk purpose of this presentation, defining terms, background, a three-level model, examples based on the model, limitations, challenges, and takeaways. My presentation bases on human-centered AI, which aims to safeguard human rights and provide individuals with the necessary skills and values for sustainable development and effective human-machine collaboration in life, learning, and work. Teachers, instructional designers, researchers, and organizations leaders will benefit from this presentation. Teachers can understand how AI applications function throughout learners' learning process. Instructional designers can develop instructional designs informed by insights into AI integration. Researchers can investigate AI-assisted learning. Grounded in a learning theory, and organizational leaders can gain insights into effective management on AI-collaborated learning. This presentation allows stakeholders to leverage AI to improve learning and equity, use AI responsibly, integrate AI into English learning, and reflect human-centeredness in the AI era. AI refers to computers which perform cognitive tasks, usually associated with human minds, particularly learning and problem solving. They adopt an umbrella term to describe a range of technologies and methods, such as machine learning, natural language processing, data mining, neural networks, or an algorithm. AI is an interdisciplinary area of knowledge and research, whose aim is to understand how the human mind works and how to apply the same principles in technology design. John McCarthy used the term artificial intelligence for the first time in 1956. The study in 1956 is to proceed on the basis of the conjecture that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. AI is the science and engineering of making intelligent machines, especially intelligent computer programs that exhibit characteristics associated with intelligence in human behavior, including, among other, faculties of reasoning, learning, goal-seeking, problem-solving, and adaptability. Artificial intelligence is an umbrella term, which has subsets such as machine learning, natural language processing, deep learning, and large language model. AI is categorized into three different types: ANI, artificial narrow intelligence; AGI, artificial general intelligence; and ASI, artificial superintelligence. Humans are using ANI as stage 1, moving towards AGI as stage 2, and will ultimately reach at ASI stage 3. Humans are currently utilizing artificial narrow intelligence, ANI, to perform specific tasks. Artificial general intelligence, AGI, aims to replicate human intelligence. In the future, artificial superintelligence, ASI, is expected to surpass human intelligence. According to SDG 4, we should ensure inclusive and equitable quality education and promote lifelong opportunities for all. Learning is a social exercise, so we need a theoretical framework to accommodate AI-collaborated learning. The community of inquiry, theoretical framework, represents a process of creating a deep and meaningful, collaborative constructivist learning experience through the development of three interdependent elements: social, cognitive, and teaching presence. The benefits of AI in education are wide-ranging, particularly in promoting improved learning and equity. AI enables personalized learning experiences that can lead to better educational outcomes by adapting to the individual needs of learners. The integration of data analytics into education management systems has evolved into more advanced learning management systems, supporting more informed decision-making and targeted interventions. Preparing learners to succeed in an AI-driven future requires equipping them with relevant skills and competencies. This calls for the development of a new curriculum that reflects the demands of a digital and AI-powered world. Additionally, strengthening AI-related capacities through post-basic education and training is essential to ensure that individuals and institutions can fully leverage the potential of AI in educational contexts. AI literacy and computational thinking skills are essential in the current era to fully leverage the benefits of AI. AI literacy involves a strong understanding of what AI is, how it functions, and how it may influence human life. Computational thinking refers to a problem-solving process that includes formulating problems in a way that allows AI to address them, organizing and analyzing data logically, and designing automated solutions using algorithmic approaches. It also involves representing data through models and simulations, as well as generalizing and applying this problem-solving approach to a broad range of situations. We have numerous learning theories why we need a new learning theory. Learning theories developed prior to the rise of AI-assisted learning have limited capacity to fully explain the processes supported by AI. A three-level model comprising the micro, meso, and macro levels has been proposed to synthesize and unify existing theories, thereby enhancing computational modeling and expanding the potential roles of AI in education. Within complex systems, the principles of evolution and complexity underscore the necessity for learning theories to remain adaptive to the dynamic, interconnected, and often unpredictable nature of education. In the era of AI, learning theories must evolve in parallel with technological advancements, as AI becomes increasingly integrated into educational environments at multiple levels. A three-level model explains the roles of AI in learning as a collaborator of human in learning. Micro level for individual learning, meso level for a group learning, and macro level for sociocultural systems learning. The three-level model unifies psychology, biology, and computer science, accommodating the roles of AI assisting human learning. Stuart Kauffman's concepts, complexity theory, and autocatalytic cycles are foundations of this model. The concepts of a dynamic causal network and homology explain chained learning processes similarly occur within a level and three different levels. The benefits of computational models of learning allows us to understand prior learning theories and provide mechanisms to simulate and test learning theories in controlled contexts. This presentation only focuses on micro-level individual learning based on Piaget, Keller, and Kauffman theory. Piaget's cognitive equilibration theory has four stages: disequilibration, assimilation, accommodation, and equilibration. Song and Keller's ARCS model of motivation has four elements: attention, relevance, confidence, and satisfaction. Kauffman's theory of autocatalytic agency explains each stage alone and mutually catalyzes the flow of learning cycle. When a learner encounters a new information, discomfort makes them to pay attention to it. In an assimilation state, the learner tries to match the new information based on their prior schema. If the learner understands using their mental framework, they directly go to equilibration. However, the learner is not sure yet. In an accommodation stage, they practice through pedagogical interventions, building confidence. When they fully integrate the new information into the prior schema in an equilibration stage, the learner is satisfied. For this presentation, I have two questions. How can we integrate AI into English learning? And how can we use AI responsibly? Disequilibration stage, AI roles as personalized recommendations, including adaptive learning paths, content customization, and dynamic feedback loops. Assimilation stage, AI roles as learning analytics, data-driven insights, predictive analytics, and educational impact. Accommodation stage, AI roles as pedagogical interventions, adaptive teaching strategies, AI-supported instructions, and teacher-student interaction enhancement. Equilibration stage, AI roles as timely assessment, individual feedback, and feedback integration. At the stage of disequilibration and attention, AI plays a pivotal role by offering personalized recommendations to support learner understanding. For example, when a learner studying travel-related vocabulary encounters the phrase "hit the road" as a new information, the AI system intervenes by guiding the learner through adaptive learning paths. It recommends an animated story in which a character says, "It's time to hit the road," before beginning a journey, emphasizing the idiom in context and contrasting it with its literal interpretation of striking the pavement. The AI then customizes content by adding the expression to the learner's personalized expression deck for daily review, and integrates quizzes that help differentiate between literal and figurative meanings. Through dynamic feedback loops, the system offers real-time clarification, such as explaining that hit the road means to depart rather than physically strike the road surface. At the assimilation stage, where learners begin to connect new knowledge to relevant prior schema, AI leverages learning analytics to reinforce understanding and support meaningful application. After the learner has been introduced to the idiom hit the road through adaptive lessons, AI begins analyzing usage patterns to identify areas of confusion and deepen comprehension. Through data-driven insights, the system monitors how often the learner misinterprets the idiom literally and determines which types of activities, such as reading, listening, or speaking, are most effective for retention. Using predictive analytics, AI anticipates potential confusion with similar phrases like strike the pavement and proactively schedules targeted practice sessions that emphasize semantic distinctions. To enhance educational impact, the system allocates additional support, such as AI-powered practice tools or teacher-led tutorials for idioms that consistently present challenges. At the accommodation stage, where learners refine their understanding and build confidence, AI delivers targeted pedagogical interventions to enhance accuracy and support individualized learning. When a learner remains uncertain about using the idiom hit the road, the AI system employs adaptive teaching strategies tailored to learning preferences. For instance, a visually oriented learner is presented with an animated story that uses visual metaphors to illustrate the idiom, while a learner who favors structured information receives a timeline comparing journey-related expressions such as depart, set out, and hit the road to facilitate contrastive learning. In addition, AI-supported instruction identifies incorrect usage and offers corrections alongside brief video clips that demonstrate the idiom in authentic conversational contexts. To further reinforce learning, the AI dashboard flags repeated literal misinterpretations for teacher attention. During a tutorial session, the teacher provides targeted examples and explains the figurative meaning, strengthening the learner's understanding, as well as fostering rapport and trust in the learning process. At the equilibration stage, where learners consolidate their understanding and gain confidence, AI provides both formative and summative feedback to reinforce learning and promote satisfaction. Following repeated exposure, guided practice, and instructional support, the learner begins to apply the idiom hit the road accurately. AI offers immediate feedback, such as affirming correct usage with messages like, "You used hit the road correctly. It means to start a trip. Great job." When misuse occurs, the system provides individualized guidance, pointing out issues with clarity. For example, suggesting an alternative to "I hit the road with a hammer" by recommending try "I hit the road early to avoid traffic." To support long-term learning, the AI integrates this feedback into a personalized summary report at the end of the idiom module, stating, "You've mastered travel idioms. Consider reviewing hit the road in speaking for greater fluency," thus encouraging continued growth. The three-level model has limitations. As a newly proposed model, it lacks empirical research evidence. It has no instrument to test the model, and the model should be validated as a learning theory through empirical research. To use AI responsibly in education, it is essential to address the multifaceted challenges it presents through comprehensive policymaking that supports sustainable development. Ensuring inclusion and equity must remain a central focus, guaranteeing that AI technologies benefit all learners regardless of background or ability. Promoting AI literacy and computational thinking skills among both teachers and students is critical for informed and effective use. The development of high-quality, inclusive data systems is equally important to support ethical AI applications and evidence-based decision-making. Advancing meaningful research on AI in education helps ensure that its integration leads to improved learning outcomes and system-wide innovation. Finally, ethical practices and transparency in data collection, usage, and dissemination must be prioritized to protect learner privacy and foster trust in AI-driven educational environments. Key takeaways emphasize the importance of adopting a three-level model of learning, micro, meso, and macro, as a theoretical framework suited to the AI era. Educators now hold an expanded responsibility to equip learners with the skills and understanding necessary to thrive in an AI era. AI should be leveraged as a common good in education, promoting equity, diversity, and inclusive learning opportunities. Advancing practice-driven research is essential to ensure AI applications are grounded in real-world educational contexts. Finally, it is vital to identify and strengthen the unique contributions of human teachers, highlighting areas where human expertise, empathy, and creativity continue to excel alongside technological advancements.